Hi, thanks for clicking. Let's try to build an application where the human resources or the HR department can upload CVs and try to question those CVs to find out which are the best candidates. Over here we've got the application can take in 2, and we have the code which can easily scale it up to as many CV as we want. The next part is where the questions are asked, and these questions can be changed. As of now we've kept it as 3, but we can increase or decrease it to our will. And then we get the output. So if the HR were to ask a question, give the number of years of experience, we'll be able to identify, okay, this candidate 2 has got 15 years, but candidate 1 does not have it explicitly mentioned. But when you click on it, you can say, okay, the LLM can give you that approximately 7 years of experience. All right, let's try to build this. Now there are going to be 3 steps to this. Step 1 is to build with the test case. Here we're going to take a sample CV and try to work and feed that into an LLM and try to build our use case from that one sample set. Step 2, we combine our learnings into a function so that we can serve it across multiple test cases. And step 3 is we put out an application using Streamlit. All right. So let's just look at the steps for step 1, because that's what we start building, and this is where the meat of the application lies. So there are primarily 6 steps to this. We get the data in the format for the model, which is effectively you take the CV, try to build it into you take the PDF, try to build it into a data format from which you can then create embeddings. Embeddings are essentially the tokens that a model uses. We'll understand intuitively what an embedding is and how far we've come in terms of embeddings. And we put those embeddings or tokens into a Vectorstore, which is effectively a database for embeddings. Then based on that, now we are ready to query the model that we would create. And once we run the model, we put the output in a data frame. All right. So now with all of these, let's get started with the first step, which is getting the data in the format that we want. So again, 3 steps to this: reading the PDFs, combining the PDF into a raw text object, and breaking into chunks. All right, so let's start to code the first part. I'm using VS Code, and any files that are built along with the data would be provided with the links, and you can work off that. Okay, so the first part is essentially getting the PDF into a text format. We basically get the PDFs, put them into a text format, and then we divide them into chunks, and we then send it off to the next stage, which is going to be embedding. So let's work off this. The example that we're going to take is a fake CV that I asked ChatGPT to build. So it primarily just gives a name, it gives the contact details, email and mobile. Then it talks about this person is a Python developer, and it talks about the professional experience. The presently working as a senior Python developer, works in APIs, has some experience with databases. Then it talks about the previous experience, and it also lists out the education, and just gives a summary of the skills that are there. All right. So now let's start in the PDF. Okay. So let's just do the first part here. For that, we're going to use PDF reader. So we would say from py PDF2, we're going to import PDF reader, and let's just read in this document. So we would say, let's just name it PDF reader also. So PDF reader, and we say, okay, this is the document. I've got a data folder, and within the data folder, I've got this fake CV.pdf. All right, let's just read it. And okay, so we got error. Let me just put this as a raw text file. All right, so we're good. So now we got PDF reader. So let's just see what does it give us. It just gives us an instance. Okay, all right, this is created. Now let's see what we have. Right, let's just see how many pages do we have in this. So all right, it's got 3 pages, which we saw when we looked at fake CV. We got these 3 pages there. That's great. So let's just try to look at one of those pages, right? So let's just say from PDF reader, let's get pages. Let's just look at the first one, and let's see what we have. So for that, we use something called as extract text. All right. So now when you look at extract text, it starts with the name, and it pretty much captures all. Let's see, where does it finish? It finishes reducing deployment time by 50%. So let's go and look at our CV, and we go to the first page. So it starts off with the name. John Smith, and the last part is reducing deployment time by 50%. All right, so we've captured that information in the first page. Now what are we trying to do with this? We're trying to take that PDF that we've just downloaded or that we just copied, and we want to get it into a format so that we want all of this not just to be about one page, but to get all of them together. So let's try to get it together in a text object. Let's just create raw text, right? Because that's what we're trying to do, which is effectively what? Second, convert it into text. Let's just put it this way. All right, so let's say convert it into text. And what are we doing here? Let's just say raw text, and we can just say, okay, this is an object. Now we will need to run through those pages. All right, so we can enumerate them. Let's say we need the page in enumerate, and we go to that particular PDF reader, and let's just do page. So once we get these pages, let's just print it out for a minute. Let's see what do we get. All right, so we're getting those three. So 0, 1, 2. So effectively those 3 pages. Not that we need I in this case. All right. What are we trying to do now? We're going to capture that content. Let's just say content equal to, and we're going to capture this content in PDF reader. So let's just say content. How do we read this? We would say we go to PDF reader. We have already got that instance, which is page, right? So we take that page, and from page we're going to extract the text. Extract text, similar to what we did before. But once we get this, we're going to update this into a raw text. So what we say is that if content is true, we want to update our raw text. So we want to update it with content. All right, let's see. Okay, so now let's see what raw text at this point should effectively have the complete resume. All right, so let's look at the last part, which says, it says certified Python developer optional. So let's look at this. So when you go to a fake CV, it says certified Python developer optional. All right, so we've got all of our details within this text object, raw text. So now let's get to the third part, which would be get chunks. So let's try to see what get chunks is about. Just let's try to understand what we're trying to do with chunks, right? So chunks is, let's try to look at this this text. All right, let's try to print it a little bit better. So let's just say print all right, print raw text. Okay, so is that I cannot practically feed the whole document to the LLM in one go. So what I'm going to do is I'm going to break it down into chunks, which could be say 1,000 characters, could be 2,000, could be 500, so on and so forth. But effectively the concept is I'm going to take this document and I'm going to break it into chunks. Say this is chunk 1, then the next one is chunk 2, right? But if you just look at this, is there any other consideration that we need to think about when you're doing chunks? The first thing is that when you build a chunk, we don't want it to be too long because it becomes expensive to run. But also we need something which is an overlap. Now what that overlap does is that if I create this one chunk, I create this one as the first one, and I create this one as the second. I want some overlap which allows the LLMs to sort of act between these two different chunks. So if I have something which overlaps, so I could effectively have this as my first, and I could sort of have this as my second. So I can see that there is an overlap between the first and the second chunks. To build this, I need to use LangChain, and what I'm going to do is from LangChain, remember we're trying to build text or chunks, so effectively it is going to be splitting the text. So let's say you're going to get text splitter, and we're going to import something called as character text splitter. Right, so effectively character text splitter, as the name suggests, is essentially going to take the text and it's going to split the character. All right, now we're going to build an instance of this, right? So let's try to build this, and let's just call it text splitter. Let's just say, right, there's a text splitter. Right, now when you take text splitter, you call upon this character text splitter, and now we're going to create an object of this. So what are the things that I want to mention in this? The first thing that I want to think about when I'm doing this is that I want to just to say, okay, how does the separator works? As we saw, that it was basically a line split, right? So that's the first thing that I'm mentioning. Okay, just giving information of how that is. Then comes the important considerations, right? And this is where once we get into practice, we would see how people are able to, experiment with this and try to see what works. But let's just keep it as 1,000. So what 1,000 here means is going to take 1,000 characters, right, for each chunk. Now comes that part, which I was alluding to earlier, which is chunk overlap. Which means, again, how much of an overlap do you want between two chunks? Let's just keep it at, say, 200, right? So 200 characters would be common. Then there is something called a length function, which we don't really need at this time, but we can just keep it as a standard, which is the default version anyways, which is a length. Use this text splitter and try to build the text that we have. Let's try to build those chunks. So now what we do is we call the text splitter, which is just an instance of the character text splitter that we built. Now when we use this, we're going to call upon split text, which is essentially what we want, right? We want to go split a text. And what is that text? Which is given by raw text. This is what we build. All right. So now let's see what text is. Let's just see what it does. All right. So it's giving us those texts. You can see it's sort of a list. Let me just see. It's effectively trying to break it down. So we're seeing that it's sort of a list. Okay, so let's start to see different parts of that. All right, so this one is the first chunk, right? Now, as one would imagine, this should be around those 100 characters, right? So this one uses 909. So now the point is, why not 1,000? It probably will have to do with the line separator that we have, right? But now let's look at the other text. Let's see how the overlap works, right? So let's do the first, and let's do the one just before that. Let's just do text, and let's look at the first element of the text. So let's try to find that overlap, which is improved performance. So where does improved performance come here? There should be somewhere here. Okay, here it is. So it says improve performance in user experience, which is the common element between these two texts. So this is the part that we specified here in the chunk side, the chunk overlap. So now what we've done, let me just come back to where we were earlier. Okay, so effectively we've done this part where we build the PDFs, combine them, and cut that into chunks. So that completes the first part, and now comes the second and third, which is effectively going to create embeddings and put them into a vector store. So I just want to spend some time to get an intuitive understanding of what embeddings are. Embeddings at the end of the day are basically converting the text into numbers. So let me just run this first line of code, which is effectively plotting numbers on a straight line. So just think about this like the bag of words approach, where you just have different numbers of the words. So you can just think about any set of words that are there, and all these red dots just talk about the number of times that they're there. I just don't think about the index. It's just the idea that I'm trying to get across. So what would happen is that you would see something on the extreme left and something on the extreme right, and you could just, based on just the simple understanding, you could say, okay, that the ones that are on the extreme left are very different from the ones that are on the extreme right, and the ones that are closer together would have some closeness to them. So that was a very basic way to get to that. Now this is as a straight line, but if you were to plot the same thing on two axes, so we've got the y-axis and the x-axis here. But so what changes now is, rather than giving it just one piece of information, just one single data point, we've now got an interaction of two of them, right? And therefore this one captures more information than the first one. So this one is just one data point. This one has two data points to build that one spot. And here again, one could sort of argue that, okay, these 2 points are closer together and would be similar from this one, right? So now what happened is that with the same concept of adding more elements to it, what Google started doing is that it started creating a vector which had all the way to about, say, 32 dimensions. So it took a large corpus of data and basically ran a neural network on that data and just tried to capture representation. So it was non-supervised. There was just no information, just trying to capture the distribution and sort of links between them. And what they found something very interesting is that within that text, that huge text that they train the data on, they would get these values. Let's say, for example, that there were these words, right? King, queen, man, woman. Let's just say that these were those 4 words within that corpus. And at the end of the training, what you would get is a representation of king as numbers of a vector of 32, right? So you would have this representation of king. It could be any number. I'm just randomly just putting numbers here. 0.2, and it will go all the way, let's just say, to minus 0.9. Let's just say like this is some number, right? So effectively the point that I'm trying to get across here is that eventually there's going to be this representation across 32 dimensions, and that one vector, as you can sort of think about this dot, the green dot here is a vector in just 2 dimensions. King would then be represented in 32 dimensions with this particular array. And the same thing you would have for queen, same thing you'd have for man, and same thing you'd have for woman. And what they noticed is that for the first time, this vector was able to capture information. So one of the famous things that they did is that they looked at king, and from king, so king represented 2 elements, right? So king represented royalty, and it also represented a man. So from king, when they did man out, what you really got was the royalty, which is this. And this was something phenomenal. So let's create our embeddings and put it into a vector database. So effectively, to create our embeddings, all right, so what we want to do in this case is, if you want to create our embeddings, we would effectively go and just import. So we'd say from LangChain, we would go to the embeddings in LangChain. From there, we're using the embeddings from OpenAI. You would say import OpenAI embeddings. All right, and then let's just create a instance of these embeddings. So let's just call it embeddings. Embeddings equal to open. Oops, I just take this OpenAI. And okay, so this is going to create an instance of OpenAI embeddings. All right. Now the next step within this part is going to be, let's get our vector database. All right, so how do we get a vector? Oh, what's happening? I can't type today. All right, so for our vector database, we'll again go to LangChain. So we go from LangChain, and over here, this looks different. All right, from LangChain, we would go to vector databases, and from vector databases, vector stores, we would import FAISS, which is basically the Facebook's vector database. So vector databases are just effectively going to store the embeddings that we're going to create. So since we're using OpenAI, we would need to go about and create a OpenAI key. So let me just copy mine over here. All right, so this is just the OpenAI key. Now, if you don't have one, you can create it. Just Google OpenAI space API key. It'll take you to a website. Just create an account with OpenAI, and you'll be able to create an API key. This is your secret key, as the name suggests. It's secret, so don't share it with anybody. So if you just quickly recall what we've done till now, we got this text, which is effectively our the CV that we'd got. So we're going to create embeddings from this. So how do we create those embeddings? We just, let's say, just call it document. Let's just call it a document search. Okay, and now from this vector database, what you want to say is, within this database, create the embeddings, and how? From text. Okay, and what are the texts? If you remember, this is the text that we want to basically put in. So we would say text, and which is the embedding that we're using. We're using the OpenAI embeddings. So once we give it this, I should be able to create the document search. So this document that we have, and we just see what this is, right? So it's going to be, it's going to say that it's a vector store. Which vector store? It's in the face. So this instance has been created. Now the fun part starts, where we're able to query the document from using the vector store. All right, so now to query it, the couple of steps that we need to follow for building a query. So first we're going to build in, a chain. We're going to see how we're going to use a chain for that. We're going to define our model that we're going to use, and then we're going to build our query, and then we do a similarity search based on the query, and we'll see why this is important, and then we final result using the chain. All right, so let's try to see. So let's start off by building up a chain, right? That's the first step that we're doing. So let's build that up and let's see how that goes. Okay, so when you're building a chain, effectively we're just using a LangChain to build a chain. So let's see what we do. So we go to LangChain and chain and say, what do we want? What from LangChain, what we want is chains and question answering. This is what we're doing. So we're going to ask a question and getting this particular part. Now what we're going to do is, from this part we're going to import the QA, or the question answer chain. All right, so this is what we're going to do is for the first element. Now since we're using our model, which is basically OpenAI, so what we'll do is, again we'll go to LangChain and we'll say, okay, this time what are we looking for? We're looking for LLMs. So which are the LLMs that we have? We're going to use OpenAI LLM. All right, so let's just import that. So let's build the chain and put in the queries post that. Okay, so the chain, we can call it chain. We get the, from here we can get the load QA, which would, so we'll be building an instance of a chain here, and sorry, just one second. Okay, here, and from here we can call in the LLM, which is going to be the OpenAI, and we need to specify which model we're using. So the model that we use for this one is GPT-3. So we can say GPT 3.5 instruct. Sorry, it will be the turbo instruct. And on the website of both LangChain as well as OpenAI, you can find the latest models that are there, and you can use this. Okay, so the next one that we're going to use is chain type. Now we're saying stuff. Now stuff in this case means we use all the data that is there. So there are different variations that you can add in terms of how you want the chain to be built, but we'll just keep it to stuff, which effectively means use everything or all the data that you have. All right, so now let's build out the query, right? So what we've done is we've built the chain, we've defined a model, right? The chain is built, define a model. Now build a query and conduct similarity search. So let's try to work on this part. All right, so if we look at building a query, which is just simply just saying, okay, what is it that you want to query for? So let's say we just want to query the CV for how many companies has the candidate worked in, and just say, and for how many years. All right, so let's just try to get that, right? That's something which probably HR would like to know, that what's the kind of work experience, but let's just sort of break it down by companies. All right, now the next thing that we got to do is work on similarity search. Now remember what we have this entire document, which was then broken down into chunks, and now we're not going to run the query on the entire chunk. We're going to say that go and do a similarity search. Now this similarity search is going to be done effectively by the vector that we would have chosen. So let's say, for example, we chose the OpenAI embeddings, and now the vector database, which in this case is the Facebook phase, was going to run a similarity search based on this, right? So let's say we want docs. Now why we say, let's say docs, that is, we're reducing this document, this entire document that we have broken into chunks. Now we want to break it down even further into components that are similar to the query. So let me just write down the code and let's see how that goes. So we would say document search. This is, remember, the embedding that we created using the Vectorstore, similarity search. And for similarity search, we would say with what? Let's say the query is equal to query. So this query, all right, let me just put it this way anyway. Let's see if the spelling mistakes are. All right, so what this is going to do, so this query is not defined. We got to run this. All right, and run it again. All right, so now see what's happened. We're saying document search, which is what the embeddings put into the Vectorstore. The vector store now is going to run a similarity search based on the query. So what the vector store would do is would take this particular query, convert it into a vector based on the one that it converted the document into, and then compare how close or how similar is this to the document, and effectively give us this. So let's just print out the docs and see what does it give us actually. What does the similarity look like? So you can see that this is a list. So let's say, okay, if it is a list, how long is the list? So that means there are 4 components to the list. Let's try to print out the first one. So let's say docs and the first one. All right. So now when you look at this, it says page content, software solutions, May 14 to 17. Now this one is similar to the question that we asked, company worked in and for how many years, right? So software solutions and this particular time frame. Let's look at the next one that it gets. So next one, it started with something else, but somewhere over here you would see again it gets the software solution part to it. So again, it's saying that all of this is more similar to the query that we put in. All right. So now, once we have this, what is the next step? So the next step is we've got all the we've taken that huge document or the CV in this case, and then we found chunks that are similar to the query that we have. And now we're going to run the chain. So the chain that we have, which we defined over here. Now this chain that we defined, which is basically saying use this particular model and use all the material. But now what is all the material? All the material is the docs, the one which we've identified as similarity search. So we've taken the document, reduced it into smaller chunks, and we're going to run this chain. And we're going to say, run it on what? It has one thing which is called as input documents. And what are the input documents? Docs, right? So these docs are the input documents. But then what you want to run it is on the question. What is the question? The question is the query. All right, so this is the question. Now let's see what we get. Now it says based on the information provided, it appears that the individual worked for 2 companies. The first company, software solution, from this time frame to this time frame, and the current is technical innovations, right? Since January 2018. All right, so let's try to run another query and see how that works, right? So let me just do one thing. Let me just put all of these things together. All right, so let's run a different query just to see how this would work. Okay, so all right, let me just put all of these things together so it's easier to sort of, let me just put the docs here, docs comes here, and your chain comes here. Okay, all right, just give me a sec to clean this up. And docs. All right, okay, so now if we just run this is the previous one. Now if you want to run a different query, let's say what experience in Python do you have? All right, we can frame it better, but let's just see what comes up, right? So based on the context, the individual has experience as a Python developer for tech innovation software present. The next step is to get everything that we've done till now into a function. So I've pasted all the remaining codes. Let's look at the function. So the function is generate text from PDF. So we have step 1 where we effectively just use a PDF reader, then generate a raw text, split the text into chunks, get embeddings, get document search, and the output is going to be the document search from the Vectorstore. All right. So next, what we want to do, remember the use case is to help HR to get those candidates. Here I've hard-coded it to 2. I would recommend that if you're trying to build a project around it, you can sort of find ways to just sort of make this dynamic based on the number of candidates you have. So I've added 3 questions here before itself. So which companies have you worked? Which Python libraries do you know? And enumerate 3. So this last part sort of forces the model to sort of give the answer to us in 3 points. So 1, 2, 3, and the third part is email ID. And of course this is dynamic, so we can keep changing to whatever we want. All right. The next is we create a data frame which effectively would just have these columns in it, right? So I've already run them before. Let me just run it again, and so let me just look how the data frame would look like. So it'll give us the candidates as an index, candidate 1 and 2. which companies have you worked in, which Python, and the 3 questions that we have. Again, you can make the columns dynamic. You can use the index can be changed to the name of the person. So you can have a question and then just use that question as an index. So you will have the name of the person here. All right. The next is we use a function which effectively calls on all the final product as a vector database. So I've taken 2 CVs, fake CV1, fake CV2, and we would just run it based on that. So now we get this document search for those, and this document search list effectively has the Vectorstore output for both the documents. Now we want to process it and run it so that it gets into the data frame. So what we're doing here is we're getting the candidate and the Vectorstore object from the candidate list and the document search list. Then we run for the query that is in the 3 questions. So we would get query for HR question 1 and then HR question 2, HR question 3. So for the first one, what we would do is we would go to the docs, create our similarity search, and then effectively run our statement, which is going to give us that output. That output we effectively want to feed into the data frame for that specific candidate and that specific query. So candidate 1, query 1 would effectively be the first location. All right, so let's see how that plays out. So the data frame would look like this. So candidate 1 and 2, which companies have you worked in? So it talks about I've worked in software company this, John Doe has worked in 2 companies. Then which are the Python libraries? So pandas, numpy, and we can experiment with the queries to get it to function. All right, so once this is done, so this effectively is going to be the output that we have, but we want to serve this output in a format where somebody can just use it as an application and not necessarily need to run through the code or need to have a Python setup so that they would be able to run that code for them, right? So at this stage, what we're doing is we've completed taking CVs and getting it into an output where the HR can sort of query. But now we're going to use Streamlit to get to a situation where they can just do drag and drop and get a situation where they can feed in the queries and get the appropriate responses. All right, so let's see how that works. All right, just a quick overview as to what Streamlit is. So if you go onto Google and see, Streamlit is a Python library which allows you to just code within your Python and be able to just deliver the app as such. So if you could just write a few lines of code, and what you'd be able to do is you'd be able to give somebody a web link where they can actually go and look at your app. And this is really helpful when you're doing any data science work or any model that you really want to put up for people to view. It sort of is helpful in terms rather than trying to get somebody to run the entire code and see what's going on. So let's try to build it now. Before getting onto the code for Streamlit, let's see how the final output would look like. So this one just gives a heading which is uploaded data files. Now since we have 2 here, we can always work on trying to make it dynamic, and we can see how we can just sort of paste 1 and then it should be done. But basically it gives you an option to upload the CVs, upload CV1, upload CV2. You can browse and put, I've just put on this, the fake CV1 and fake CV2. Then it gives the option for placing in the questions. So 3 of us, if you recall, it will be from HR question 1, HR question 2, HR question 3. And then the data frame, which is going to be your final output, will come here. Candidate 1 and 2, which companies have you worked for, which Python libraries, and so on and so forth. And you have this. Now you have the option of pretty much just changing the question over here. And the moment you make any change, it prompts you to say press enter to apply. And the moment you make any change, what Streamlit would do it'll run the code as in the background, and then it would make the change. So your final output is now changed. So the change from email and contact, we now only have email, and we can only get this. All right. So keeping in mind that we have these different blocks, the final output, the questions, and the data files to upload, let's get to the code and see how that works. All right. So let's look at the Streamlit application of the Python code for that. Close to about 90% of the code is essentially what we've already done. And just about 10% is what Streamlit does, right? So we just import Streamlit as ST, the other one, import Streamlit color. This refers to a Python file which effectively is just going to build your color templates, right? So we don't need to know any of this. We can just copy it, and it is just going to give us the background color, the text colors, and just build out the colors for our page. And quite frankly, you can also skip this part if you don't want to do that. So we get a Streamlit, we get all the libraries and that we would need for running our code. We would call upon Streamlit color, the main function, which is effectively the other main function that comes from the other Streamlit color Python file. And then we do pretty much what we did last time, which would be give it the OpenAI key. For Streamlit, title is what comes up as a title for the file. So you can say upload data files. If you recall, when you want to give those upload, it just gives that as a title. And then we can use st file uploader, which prompts the user to upload the first data file, right? So it's a file uploader function, which will just go and upload that file. It's going to give that as a prompt, and it accepts only PDFs. So if it does not have a PDF, it's going to give an error. If you want to include more types of documents, you can put in more. Like if you want a docx, so you can just put comma docx over here. It'll take a document function, a Word document also. But as of now, we just restricted it to PDFs. All right. Then what you want to do is that if both of these are there, then it's going to give out a message once it runs through the stage and sees, okay, both CV1 and CV2, that means the documents have been uploaded. We would give out an output. Streamlit is going to give an output, which is going to be file successfully loaded. So the user is going to see that output come up. Then we again call upon the same generate text from PDF that we'd got earlier. Does exactly the same thing. Generates that same. We're moving towards generating the data frame with candidates 1 and 2. ST again is going to give a title, search CVs for. It's going to prompt, again the text input is going to prompt the user to fill in the questions. And what the value function does is it predefines an input to it. So when you saw the Streamlit app open up, it had these 3 questions already fed in, right? Email, contact number, and so on and so forth. This would be the value that will be the default value, and the user can change this. Okay. Then the next part is we build a data frame. After building a data frame, we effectively just run those generate function, which is going to give us the document search. The same thing that we've done just recently, document search list. We run it in a chain, we create a data frame, and once the data frame is there, the Streamlit application would give a title, it would say final output, and then it's going to go ahead and write the data frame to that. So this is our function, right? So what we'll do is now go ahead and run it. So when we run it in terminal, what we need to do is you can open up a terminal and just say Streamlit. Remember, it will not be Python. We would have to say Streamlit and then say run, and Streamlit run, and you can say Streamlit application. All right. So when you run this, it's going to go ahead and run the entire application, and it's going to give you 2 choices. One is going to be a local URL or a network if you wish to share with somebody. Let me just open the host one, and it automatically opens it up for you. Okay, let me just bring that in. Okay, so now again you would have upload data files. It'll give you the option of doing that. Now see, there's nothing else that's over here, right? But the moment I would go ahead and select those files, I would go ahead and see those files come up. So I can have fake CV1, and I select the second one. I can just upload, like it's just a lot of uploading as if you're doing it anywhere else. You get your fake CV2. And then the moment these are loaded, the file successfully loaded, you know that this would be that part that we wrote where st write. So it's going to give that output, then search CVs for, and as these 3 questions come, it's going to generate the final output, which is going to be here. Put forward a link, which would give you the Streamlit application, this application along with Streamlit color, the 2 documents that we have, as well as the application. So I've not put forward this is more for our understanding, but I'll give you the neater version of this so that you can actually just use it and work through. All right. I would strongly encourage you to try to make this as dynamic as possible so that you can have this as a project that you can showcase and just have some fun with. Thank you so much for listening to me, and wish you all the very best on your journeys. Thank you.